Every business operates under constraints. Some of the constraints businesses face are we only have so many dollars to spend on inventory. We only have so much space to put that inventory in. We only have so many people who can only work so many hours. We have so many machines that can produce so many goods. So the question is, if you own a business and you operate under constraints, as all businesses do, what is the maximum revenue that your business can generate given those constraints? To answer that question, we need to make an optimization model, or in some cases it's called an allocation model, where you allocate limited resources to determine what is your maximum output. In the example we have in front of us, we've graduated from Penn State and opened up a coffee shop. We make 3 types of coffee: regular brewed coffee, premium cafe latte, and premium cafe mocha. The regular coffee sells for $1.25 a cup. Cafe latte sells for $2, and cafe mocha sells for $2.25 a cup. We have some constraints. We have storage facilities and merchandising constraints that allows us to only sell 500 cups of coffee a week. A total of 500, not 501. So our total output has to be 500 or less cups of coffee a week. Additionally, we have some chocolate constraints. We may not have enough money to buy all the chocolate we want, or some other constraint. But at the end of the day, we only have enough chocolate on hand to make 125 cups of mocha in a week. Additionally, we have a small refrigerator in our new coffee shop, and that refrigerator can only hold enough milk to make 350 premium cups of coffee in a week. And we have 2 premium types of coffee. We have premium latte and premium mocha. So both of them added together must be less than 350. So given these constraints, what is the maximum revenue that our coffee shop can produce? Very important we know that, so we know how much we can spend. Will this be a profitable business, or will we have to change our business model? So the first thing we do is we identify our variables. The variables are those items which will change in value to give us an optimal solution, which is the optimal revenue. Well, the things that are changing in value, the values will be changing, are the cups of coffee. The number of cups of regular coffee, the number of cups of latte, and the number of cups of mocha. And I've identified those 3 variables up here as X1, X2, X3. You can give them any variable name you would like, coffee 1, coffee 2, or coffee 3. But there are 3 things that vary in our model, and that is the number of cups of coffee of each of our 3 products. The next thing, we have 3 constraints. The first constraint, as we mentioned previously, is we can only produce 500 cups of coffee because of storage facilities and merchandising. We can only produce 125 or less cups of coffee of mocha because of limited chocolate space, and our total premium because of milk refrigeration limitations is 350 cups or less. So in this area of our model, I made space to determine those constraints. And finally, we have our optimization, our maximization formula. And that's very simple. We take the optimal numbers of each cup of coffee, multiply it by the sale price of each cup of coffee, add it together, and we'll have our optimal revenue for a week. So let's go back and again, let's color code this so we can see this. These are the 3 cells where our coffee, our optimal numbers of cups of coffee for each of those cells will appear. F2, 3, and 4. Here in the constraints, we need to translate these logical constraints into formulas that Excel will understand. So let's do that. The first one is equal F1 for the number of regular cups of coffee, plus F3 for the number of cups of premium latte, and F4 for the number of mochas. There it goes. The next constraint is X3, or the number of mochas, and X3 will be represented in F4. So where are these numbers coming from? They will come from when we solve the model. Excel solver will actually put the numbers in those blank cells. And finally, X2 and X3, so the number of lattes plus the number of mochas have to be less than or equal to 350. And there we go. And then finally, the last thing is we need to translate this formula, and that's easy. $1.25 times the optimal amount of regular coffees, and that value is going to be placed in the cell F2, plus $2 times the optimal number of premium lattes, which will be placed in cell F3, plus $2.25 times the optimal number of premium mochas, and that value will be put in F4 when the model is run. And there we go. So, next step is go under Data tab, select Solver, and simply tell Excel where everything is. The first, set objective. That's the optimization. That's our objective formula. So where did we place the objective formula? We placed it right here in F15. Okay. What do we want to do? Maximize or minimize? Well, obviously we want to maximize, so we make sure that radio button is selected because we're maximizing our revenue. And what cells are we changing? Well, those are the cells where our variable values will be. F2, 3, and 4. Select those. Perfect. And we have 3 constraints. Now, we translated the logical formulas into Excel formulas, but we didn't put in the Boolean operators, the constraints. So we need to do that, and we need to add 3 of them. So we click Add, and the first cell reference, and we go over here, is F10, and F10 has to be less than or equal to 500. Click Add. Our next cell reference is F11, and F11 has to be less than or equal to 125 cups. Add that. And our final third constraint is in F12. And F12, whatever number is in F12, has to be less than or equal to 350. And since that's our third constraint, we don't need to click Add. We click OK. And there we have. So we have our objective cell where our optimization revenue formula is. We're maximizing that. We're changing 3 cells, F2, 3, and 4, and we put in our cells that define our constraints. We can't make a negative amount of coffee, so we make sure that is checked, non-negative variables. And at this point, we're going to solve. So we simply solve. Do we want to keep the solution? Yes, let's keep the solution to see what it is. And there it is. Beautiful. If given the constraints that we have, the maximum, the optimal number of cups of coffee we can make is 150 regular cups of coffee, 225 premium lattes, and 125 premium mochas. Now, we know those have to add up to 500, do they? They do. We know that X3 has to be less than or equal to 125 when we find the optimal solution is 125. And we know that the premium has to be less than or equal to 350 because of MEL constraints, and it is. So when we take into consideration those constraints, we will be able to make $918.75 maximum revenue per week in our coffee stand given these constraints.